In problem 16, we have a car traveling on a straight road with a velocity of 55 feet per second at time t equals 0. So I know v of 0 is equal to 55. On the closed interval from 0 to 18 seconds, the car's acceleration is the piecewise linear function defined by that graph. And the first question asks, is the velocity of the car increasing at t equals 2 seconds? Why or why not? So we start out by saying that velocity increases when its first derivative is positive. So velocity will be increasing when acceleration is positive, since at time t equals 2 the acceleration is positive, therefore velocity is increasing. So that's part A. Part B asks, at what time in the interval from 0 to 18 other than 0 is the velocity of the car 55 feet per second? Well, from the graph we know we start off at 55 feet per second. Then since acceleration is positive, as we sweep to the right, we're increasing velocity all the way up to 6. When acceleration becomes negative, we start to decrease velocity. So all we need to do is to find a point at which the velocity we added after time t equals 0 is equal to the velocity we subtract after time t equals 0, so that the increase and the decrease will zero themselves out. And just geometrically you can see that that will occur at time t equals 12. So at time t equals 12, the increase in velocity from time t equals 0 to time t equals 6 will be exactly matched by the decrease in velocity from 6 to 12. And that will bring the car back to a velocity of 55 feet per second. And that should be fine for answer B. Now I'll give a mathematical way of stating that also. We'll say that v of t will be 55 whenever the net change from t equals 0 in velocity is 0. And the net change in velocity is given by the area under the acceleration curve. And the only time when the net change will be equal to 0, that integral from 0 to x will be 0, is at x equals 12, t equals 12. So that short mathematical answer would have sufficed for all the writing in green there. Let's go on to part C. We're asked on what time in the closed interval from 0 to 18, on the time interval there, what is the car's absolute maximum velocity and at what time does it occur? Once again, I will invoke the extreme value theorem. And by the EVT, the absolute maximum velocity will occur at critical values. And a critical value will be where the derivative of velocity changes sign. In this case, where acceleration changes sign at t equals 6 or t equals 16. Or it may occur at the endpoints, at t equals 0 or t equals 15. And so all we have to do is to test the velocity at those 4 values. Now one of those values, t equals 6, is going to be a relative, at t equals 16 is going to be a relative minimum. But let's start out. V of 0 is 55, we know that. From 0 to 6 we increase velocity, and you can find that in that trapezoidal shape there, that we increased by 60 units. And so v of 6 is going to be 55 plus 60, which is 115. As I said before, v of 16 is really a relative minimum because the derivative of velocity, acceleration, changes from negative to positive. And I can calculate that if I wanted to, but it can't. The absolute max can't occur there. Well, if I wanted to calculate it, I have a negative 60 from 6 to 12, and then from 12 to 16 I have a negative 45. I was at 115 at t equals 6, and I'm countering that with minus 105. So the velocity will be 10 feet per second at t equals 16, and we'll add 15 more feet per second by the time t equals 18, so v of 18 will be 25. And so the absolute max occurs at time t equals 6, and that velocity is 115 feet per second. Part D asks, at what time on that interval, if any, is the car's velocity equal to 0? And I state that since v of 0 is 55, and the absolute minimum is at t equals 16, v of 16 is 10, by the extreme value theorem, then there is no place where v of t is equal to 0. And that wraps it up for problem 16.